Good morning, students. In the last class, we discussed about the inductive effect, which is experienced in the reaction mechanism or which is exhibited in the reaction mechanism by the transfer of sigma electrons. Understood? So, first one is inductive effect, as I told you. Two types is there. One is plus I effect, another one is minus I effect. So plus I effect is going to be exhibit when electrophiles are attached to them. Minus I effect is going to be exhibit when nucleophiles are attached to them. Electrophiles, that is electron releasing groups. This one is electron withdrawing groups. Means if positive charged species are attached to the R group, then they exhibit plus I effect. If negatively charged species attached to this I means that R group, if there is CH3 benzene anything, then they show what? Show what? This minus I effect. Understand? So later you came to understand. Listen, students. Some electron withdrawing group and electron releasing group I give. So electron withdrawing group means which withdraws electrons. Okay. So it may be Cl minus, OH minus, and then COOH. Don't take minus, just take bond. COOH, CHO, SO3H, NH2. Cn, etc. Means almost negatively charged species. Listen, Cl minus, OH minus, COO minus, CHO, SO3H, NH2 minus, Cn minus, etc. Almost all nucleophiles. Okay? So, an electron releasing groups are alkyl groups only. Electron releasing group nothing but only alkyl groups like CH3, C2H5, C3H7, etc. Understand? So that means electrophiles are different, nucleophile is different, electron releasing groups are different, electron withdrawing groups are different. Listen, Cl2 is there, assume. If Cl minus also there, Cl plus also there. If they undergo heterolytic cleavage, they form Cl minus as well as Cl plus. So this one is nucleophile, this one is electrophile. Because it is positive charge, this is negative charge. But these two are Cl atoms only. But this Cl minus or Cl plus, both are what? Electron withdrawing groups. They withdraw the electron. So there is a common what is idea about this plus I and minus I effect is, that is electrophiles are attached, then it exhibit plus I. Nucleophiles are attached, then it exhibit minus I. But the terms nucleophile and electrophile doesn't define completely electron withdrawing and electron releasing character of the groups. So listen, Cl minus, as I told you, Cl plus is there, or NO2 is there. Here you have NO2 also. NO2 is also an electron withdrawing group. Understand? But listen, NO2 plus we written. In the before class, in the electrophile, I gave an example NO2 plus. NO2 plus is a electrophile. So according to this, it must be a electron releasing group. But this NO2 is a electron withdrawing group. So there is quite difference in electrophile, nucleophile, electron withdrawing and electron releasing. Don't confuse, all electrophiles are electron releasing. All nucleophiles are electron withdrawing. That is wrong. Understood? So some of the electrophiles also acts as an electron withdrawing group. Only remember, if alkyl groups are there, only alkyl groups are electron releasing. Except alkyl groups, all are electron withdrawing. Only alkyl groups are electron releasing. Except alkyl group, hydrogen and alkyl group. Hydrogen also you may take. Hydrogen H plus ion. That hydrogen and this alkyl groups are what? Electron releasing group. Except these alkyl groups, each and every atom bond to the any R group Okay, it may be a alkyl group or a aryl group. It may be a benzene ring or a straight chain. So that is what electron withdrawing groups. Remember that only simple concept is there. If CH3 is attached, electron releasing. If except CH3, any other atom is attached, that is electron withdrawing. Understand? Okay. So in the tomorrow's class, I explained inductive effect. That inductive effect is exhibited by the molecules by what? Transfer of sigma electron. And it is a complete transfer of electron. Means if CH3, Cl is there, okay, this carbon is having different electronegativity, this Cl is having different electronegativity. So based on the electronegativity definition, of course the electron of carbon is moved towards the Cl atom. So it dissociates as what? CH3 plus Cl minus. So this atom experiences which type of inductive effect here? Minus I effect. Why minus I effect? Because this withdraws the electron. This is withdrawing the electron from this. If minus species are attached here, if you dissociate, it is dissociated as Cl minus, then it is minus I effect. If any reagent attached to this R group, if it dissociates as minus, then it is minus I effect. Means the inductive effect is introduced or caused by the presence of this one, negative species. That's why it is minus I effect. Understand? Listen. Withdraw means what? Remove. Removal of what? Electron. Electron is in which charge? Negative charge. So that's why it is negative inductive effect. Whatever the may you want, you may consider the definition. But you have to remember if the nucleophile, especially negative charged species are there, then it exhibits minus I effect. Listen, another one I will say. This is CH3, H means CH4. So it is dissociated as CH3 minus plus H plus. Okay, here the dissociating species is what? Positive ion. So here we are experiencing what? Positive inductive effect. Means the inductive effect to this R group is by the presence of this electrophile. Understand? That's why it is positive inductive effect. And as I told you, this group is also an electron releasing group. This H and the alkyl groups. Understood? Okay. Next we will go to electromeric effect. Very important effects these are. Electromeric effect. Okay. So students, this electromeric effect takes place in double bond. And not only double bond, multiple bond. I will take double bond. Or instead of double bond, you take pi bond. This electromeric effect can be exhibited by the compounds having pi bond. This one is sigma bond. This one is pi bond. Difference is important. Okay. Listen. And of course, here also two types is there. One is plus C effect. Another one is minus E effect. Initially, I write the characteristics here. Next, this effect is temporary, whereas this one is permanent. This one is temporary. Next, it takes place in presence of. It takes place in presence of attacking reagent. It takes place in presence of attacking reagent. Listen students, I am going to explain this detailedly. What is this electromeric effect? And this is also called as electronic effect. So I will take a simple example. CH2 double bond CH2. What it is? Ethane. Here one sigma bond is there, one pi bond is there. So each bond is made up of what? Two electrons. Okay, here we are not disturbing the sigma bond. We have to consider only pi bond electrons. Understand? This is CH2, double bond CH2. So in the yesterday's class, I told you already, the what is transfer of electrons takes place from atom to pi bond or adjacent bond position like this. So why is there double bond is there like this? If they transfer like this, in the yesterday's class I told, or they may transfer to the next bond position. Understand? So these are the mechanisms going to occur during the reaction. So in electromeric effect, what happens? This electron shift to on either side of the bonds, either left hand side or right hand side. Okay? So assume these two electrons are completely shifts means we have to show like this. If only one electron is shifting, we have to represent it with a single arrow or a fishhook arrow. Okay, so complete electrons are transferred means that is written like that. So then what happens here? This CH2 and their bond completely shifts means it becomes CH2. Listen, this carbon atom already have its electron and this electron is also shift towards this carbon means this will get the minus charge, this will get the plus charge. Okay, this is the reaction going to or the mechanism or the electron displacement takes place in electromeric effect. Okay, the effect exhibited by the transfer of pi electrons to the adjacent atom, that is called as electromeric effect. Understand? So this electromeric effect alone cannot take place. Means if CH2 double bond CH2 is there, alone it cannot form CH2 plus and CH2 minus, because like ethene, this is already a stable compound. But here if you consider CH3OH, even in presence of any reagent or in absence of any reagent, easily they break each other, like CH3 plus and OH minus, because it is a sigma bond. These two are different electronegative atoms. The bond will break means easily they form CH3 plus and OH minus. There is no need of presence of any extra attacking reagent. ಅಂದ್ರೆ ಇಲ್ಲಿ CH3OH ಇದೆ ಅಲ್ವಾ, ಇದ್ರ ಜೊತೆ ನಾವು NaCl NaOH ಹಾಕ್ತಾ ಇರ್ತೀವಿ, HCl ಹಾಕ್ತಾ ಇದೀವಿ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. CH3OH HCl, then they form what? CH3Cl plus H2O. Even in presence of a reagent or in the absence of a reagent, they dissociate in the same way. Understand? So in the inductive effect, there is no need to presence of any attacking reagent. But in this electromeric effect, the pi bonds can have the ability to shift only when the attacking reagent is present. Understood? So then what happens? This CH2 double bond CH2 is there. It alone cannot form CH2 plus and CH2 minus, because this is unstable, this is stable. Understand? So instead of that, if you add any groups there, listen, this is CH2 double bond CH2. Assume. So if here any electrophile is there, or H plus I take. H plus I take. So when the presence of H plus ion is there, understand? Then what happens? Initially, by the presence of this electrophile, the electron transfer takes place. In which way? This way. One will form CH2 plus, another will form CH2 minus. Remember here students, the attacking reagent is the electrophile plus charge. Then it goes to which carbon atom? Carbon atom with the minus charge, because plus is always bonded to minus, minus is always bonded to plus. Understand? So here what happens? Electron also shift towards this carbon. This is carbon number 1 you take, so 1 you take, this is carbon number 2 you take. Okay, and same, this electrophile, the species with the positive charge, is going to attack to this carbon atom. Carbon atom 2. This one is 1, this one is 2. Electrons are also shifted to the carbon 2 and the reagent also attached to the carbon 2. Are you getting? And another way may be possible if CH2 is there, double bond CH2 plus Cn minus. Okay, then same, the displacement of electron takes place. This is like CH2 plus and CH2 minus. So the here attacking species is minus in charge. Then it is attached to the which carbon atom? Plus carbon atom like Cn. Because this is minus in charge, we have to neutralize. Then it is attached to the carbon atom with the positive charge. Understood? So that means, listen, here what happens? In the both the case, electron is transferred to the carbon atom 2 only. This is also 1, 2, 1, 2 if you take. In both the case, electrons are transferred to the carbon atom 2. Okay, for your convenience and I number the carbon atoms 1 and 2 like that. Okay, so listen, in this case, electron also transferred to the same carbon and at the same time, attacking reagent is also attached to the same carbon atom. Okay, in this case, the electrons are transferred to the one carbon atom and nucleophile is attached to the other carbon atom where the electron is removed. Understand? So this type of effect in the positive charge, this is plus E effect, this one is minus E effect. This one is plus E effect, this one is minus E effect. Understand? Okay, this is not effect, this is just simply a movement of electrons. Okay, so in the presence of how the electron shift takes place, I just showed that. Okay, listen, this is electromagnetic effect itself. This is electromagnetic effect, means shifting of pi electrons takes place. In the types is there. This one is the plus C, this one is the minus C. Okay, so listen, what is the definition for that means? So, if the attacking reagent goes to the carbon where the electron transfer takes place. If attacking reagent goes to the same carbon where the electron transfer takes place, that type of effect is called as plus E effect. Okay? So what is minus E? So the attacking reagent which goes to the other carbon atom in which the electron is not transferred or electron is completely transferred to the other atom. Means here the electrons are shifted here, but the reagent is attached here. Okay, so the reagent which is attached to the other carbon atom or other than electron rich carbon atom. This is electron deficient, this is electron rich, you know that. So whatever the way you have to define, you can define that. No matter, this is the correct rule to express this. Now what is that? Definitions. They want as definition. They just ask what is electromagnetic effect, what is its types, or give example. What is mesomeric? This inductive effect. Give an example. What are their types? Only that much they will ask. Main definition of effects. Not what is plus I effect, not what is minus I effect. They won't ask like that. Understand? But you have to understand when the plus I effect is going to, plus E effect is going to exhibit, when minus E effect is going to exhibit. And I told you, only in presence of this electrophile and the nucleophile only, they exhibit plus E and minus E effect. So if we remove them, assume, if we remove them, then again they become what? The CH2 plus and CH2 minus is there. Here Cn minus is there, assume. So if we remove this electron rich species, that is nucleophile, then what happens? Of course it forms CH2 double bond CH2. Means once we remove the attacking reagent, again they become original molecule. That's why it is temporary. Means the effect can be exhibit only in presence of the attacking reagent. If attacking reagent is removed, then this effect is also disappeared. It is not a permanent effect. So if attacking reagent is present, then effect is possible. If attacking is the difference between inductive and electromagnetic effect. It's very important for 2 marks. Inductive effect and electromagnetic effect. Okay, so students, first one is the definition. This inductive effect is the transfer of electron of the sigma bond based on difference in electronegativity of atoms. Electronegativity of atoms. Next, this one is one transfer of electron of pi bond in presence of attacking reagent by the influence of attacking reagent. That is what this is inductive effect, that is electromagnetic effect. Next, second one, it is permanent effect. It is permanent effect and this is temporary. You have to write effect. So it is permanent effect, it is temporary. This is temporary effect. Okay. Next. Another one. It takes place alone or in presence of attacking reagent. Next, takes place only in presence of attacking reagent. Okay, so this one is this one for polarity in molecules. I will write this exhibit or this causes. This causes polarity in molecules. This cannot form or cannot cause polarity. So this is the difference between inductive effect as well as electromagnetic effect. And listen here, in the right. So this effect vanishes after 3 carbon atoms. Okay. This cannot vanishes unless attacking reagent is removed. Unless attacking reagent is removed. So students, remember, if any one reaction mechanism is there, in that reaction mechanism there is a possibility of two effects can be simultaneously exhibited, like electromeric as well as inductive. So in that time, electromeric effect predominates this inductive effect. Means the effect which is greater effect on the one which affect very strongly with the organic molecules. Our organic reaction is electromeric rather than this inductive. Understand? Means in the same reaction, both can happen. In that, the predominant is what? Electromeric. Means electromeric predominates inductive. This is stable, this is less stable, like that. Understand? Okay. So listen, I'll give one example for that, then you'll understand. Listen, and take CH3, CH2, double bond, CH, Okay? Assume it is like that. Here, there may be a possibility of two effects. One is electromeric, another one is inductive. So, inductive by which? Okay, inductive by which effect? Like this, bond breakage takes place, and this one is highly electronegative. It must be like CH2 double bond CH plus Cl minus. One possibility like inductive effect. Inductive effect. Next, if it is electromeric, that is CH2 double bond CH Cl. Electron shift may take place to this or this. Listen here, Cl is there. Here, these electrons are there, and obviously, electron shift towards this. Then it forms CH2 minus single bond CH2 plus Cl. Then here what happens, if any electrophile is there, that is going to attach here, here Cl is there, that is very strong bond with respect to this. Understand? Of course, this is the stable breakage of our electron bond or electron transfer takes place. Among sigma bond and pi bond, which one is stable? Means we know that there is pi bond. Preference is given to pi bond only. Here also in the same manner, the sigma bond breakage is there, pi bond breakage is there, as I told you. So the pi bonds are less stable than sigma bonds. Means pi bond is weak bond, sigma bond is strong bond. Understand? So that's why the transfer of pi electron is easy than sigma electrons. Here sigma bond should, so the breaking of sigma bond takes place, here breaking of pi bond. Understand? So this effect takes place very easily than this. That's why electromeric effect, this is the effect, electromeric, predominates always inductive effect. So means in the same molecule, both inductive is also there, electromeric also there, then the electromeric effect is highly stable and it predominates over what is the inductive effect. Understand? So order is there. I told you four type of effects are there. One is inductive, electromeric, resonance, and hyperconjugation. So inductive is less effect. So this is then electromeric, then resonance, then hyperconjugation. Means this is the most predominant effect. This is the least predominant effect. Means in the same reaction, inductive is also there, resonance is also there. Preference means the effect is most efficient is what? Predominant effect is resonance. Resonance is there, electromeric is. Resonance is predominant. Hyperconjugation and resonance is there. Hyperconjugation is predominant. Understood? So this is what the order of the effects. So we discussed inductive, we discussed electromeric. Now we will go to the resonance effect. Understand? I hope you already know about resonance. Okay, so resonance effect, also called as Mesomeric effect. Okay, resonance effect and Mesomeric effect, represented by R capital F. So in this also type is there, one is plus R or plus M minus. So initially I will explain what is mesomeric effect, and this are a resonance effect. This can be observed in the pi bonds with, I told you, here double bond is there means the bonds are shifted to the adjacent bond position. This pi bond is shifted to the adjacent bond position. This type of electron displacement takes place in the not that in electro, what is it? In inductive effect, of course, breaking of the bond takes place in that here bond is like this. So it will be like this. Means the pi bond electrons is shifted to the adjacent atom. This one. What I explained before, electron electron. Now, so this pi bond electron is shifted to the another bond position. So they causes like this. Only the bond position varies. Means, so this effect is going to exhibit by the delocalization of pi bond electrons. This one is the pi bond delocalization. Of course, locality means one position. From one position to another position, that is delocalization. Okay? So from one position to one position. What is that position? That is the bond position. Bond position of what? Pi bond. Means the delocalization of pi bond electron takes place. That results in what? Resonance effect. Reason ನಾನು ನಿಮಗೆ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ತೇನೆ. ಇಲ್ಲಿ ಬೆನ್ಸೀನ್ ಸ್ಟ್ರಕ್ಚರ್ ನ ನೀವು ತಗೊಂಡ್ರೆ ಇದಕ್ಕೆ ರೆಸೊನೆನ್ಸ್ ಸ್ಟ್ರಕ್ಚರ್ ಆಗಿ ನೀವು ಈ ತರ pi bonds ಅನ್ನ ಡಿಫರೆಂಟ್ ಬಾಂಡ್ ಪೊಸಿಷನ್ಸ್ ಅಲ್ಲಿ ಬರೀತೀರಾ ಈ ತರ. You know that benzene can be written like this or like this because these inner 5 electrons, the 6 electrons are delocalized. They are revolved, they are not fixed to this carbon, this carbon, this carbon. They are completely delocalized. The movement of electron, they are like this. They are completely revolving, they are not fixed at the position. They belong to all the carbon atom. That is called delocalization. Because of the delocalization only, they form resonance structures. Understand? Another one I take ozone, you know that. If ozone is there, it will be like this. You may also write the equivalent structure. Resonance structure like double bond here. These two may be the, what is the structure of ozone? Means the pi bond may be present here, or they shift here means the pi bond may be present here. So these two are the resonance structures, but these two are ozone only. Understand here what happens? This is a pi electron, its position is here in between 1, 2, 3 and 1, 2, 3 means initially the position of the pi bond is in between first and second oxygen atom. Here the position of the pi bond is in between second and third oxygen atom. Means only the position of the bond changes. Understand? That is because of what? Because of delocalization. This is the initial locality of the pi bond. It delocalizes from ear to ear. Just it displaces its position. Understand? So this is what? Resonance effect. So I'll write down how the resonance effect takes place by the delocalization of the electrons. I'll take the example benzene here. So this resonance effect means the delocalization of pi bond electrons causes polarity in the molecule called as resonance effect. Okay, called as resonance And this effect is called as resonance effect. Okay, listen, I'll take the example of benzene here. So this is a benzene with 5 electrons. I'll number the atoms here 1, 2, 3, 4, 5, 6 for our convenience. So here the 5 bonds are in between these. So listen, if I take the resonance structure, I'll take this again, benzene ring. So 1, 2, 3, 4, 5, 6. Listen students, here each bond consists of a 2 electron, correct? So consider this one, the first 5 bond in between 1 and 2. So here, so this carbon consists of this electron, this carbon consists of this electron, correct? And third carbon of this, this electron is for third carbon atom, this electron for fourth carbon atom. This is for fifth, this is for sixth. You know. Then what happens? These two high electrons completely transfer to this, like this. Completely transfer to this second carbon atom. Means, listen, here as it is, the bonds are here in between 4, 3 and 6, 5. Only here changes takes place. Here this electron belongs to second carbon atom, means that is neutralized. At the same time, the electron of first is also shifted to second. Understand? Means it is like this. 2 electrons, complete 5 bonds, is shifted to what? Adjacent atoms. So this is the atom, electron of the same atom. 1 electron is more. That means what? Minus in charge. Electron completely shifts here means minus in charge. Okay, so I'll write electrons first. This electron, because of this electron, they get the minus charge. Here, of course, 1 electron less. That means the first carbon atom gets plus charge. What is that? Delocalization of 5 bond. Okay, how the delocalization takes place later I will say. So electron causes polarity. Polarity means plus and minus charge. Understand? So delocalization of these electrons results in the polarity, that is called as what? Resonance effect. Listen, again I take the same benzene ring. First, second, third, fourth, fifth, sixth. In the second carbon atom, we have already minus charge. I won't write this lone pair of electron next. Okay? So, loading E L2 electron, complete 2 electron, ಇಲ್ಲಿ shift ಆಗ್ತಾ ಇದೆ. Okay? Then what happens? Just like the bond here, this one is here, this one forward here. And we cannot form like this. Adjacent agi bonds irokke chance illa. ಅರ್ಥ ಆಗ್ತಿದೆಲ್ಲ? Then what happens? This electron again shift to the carbon atom 4. So then here it will get the minus charge. Then here it become neutralizes and this become plus. Changes ಗೊತ್ತಾಗ್ತಿದೆಲ್ಲ? Okay. Next. Similarly, these electron shifts here and these electron shift to this carbon. Then the bond formed is here, bond is formed already here, and here also the shifting takes place here in between 4 and 5. The bond is formed here it will get minus, here it will get plus. Okay, next here extra electron is there, you know that? These shifts here. This electron shifts here. That means the benzene ring with one bond position here, another here. So plus and minus balances. Then here first carbon atom, second, third, fourth, fifth, sixth. Compare first and last. What you are getting? Initially, the position of the double bond is between 1 and 2 carbon atom, they are 2 and 3. Next, in between 3 and 4, they are 4 and 5. In between 5 and 6, and they are 1 and 6. Means the position of the double bond changes. That is what? Delocalization. This is the first exact position, initial position, that is the final position. So resonance hybrid, you may write like this. So this will be written like this. So this represents what? All the 5 electrons are delocalized with all the carbon atom. They are not fixed for one position, particular position. Understand? This is what resonance effect. Delocalization of pi bond electrons causes polarity in the molecule. The plus and minus of this benzene ring is due to what? The delocalization of these electrons. Which electrons those are? Pi electrons. Okay, so in these two effects are there. One is plus R effect, another one minus R effect. So I will explain that plus R and minus R effect in the tomorrow's class. Okay, you just remember, listen. These two are the, I'll take this one as structure 1, structure 2, structure 3, structure 4, this one is 5, and this one is 6. So students, here, structure 1 and 4, sorry, 1 and 5 are resonance structures. Resonance structures, and structures 2nd, 3rd and 4th are canonical forms. Canonical forms. And the last 6th one is resonance hybrid. Resonance hybrid. Sorry. This one is canonical form. This one is resonance structure. This one is canonical forms. This one is resonance structures. Okay. Listen, students. So then after that, in that we can also say resonance energy. What is this resonance energy means? It is the minimum energy of any one of the resonating structure or any one of the canonical form. So here 5 is there, 1, 2, 3, 4, 5. Among these 5, any one of the compound exhibits minimum energy. Okay, the minimum energy exhibited by the canonical form is called as resonance energy. Understood? And that compound which exhibits the lowest resonance energy, that is the exact structure of the respective compound. For example, 1 and 4 is in the silicon. In this 1 and 5 structures, of course, these two have same resonance energy. ಇದಕ್ಕೆಲ್ಲ unstable ಇದೆ, plus minus charge ಇದೆ. They become unstable. They have high energy. But this first and fifth structure, they are stable. They have least energy. That's why the first and fifth are the structures of benzene. Understand? So in the canonical forms, understood? One which have the least resonance energy, those are considered as the exact structure of the molecule. Understand? So this is what? Resonance hybrid. What is this resonance hybrid? This is the final structure we are going to get by the delocalization of the pi electrons. Okay? So this is all about the resonance. In the tomorrow's class, I will explain types of resonance effect. Okay? Thank you.